The shock waves. A brief introduction to the shock waves. Shock waves can be defined as the disturbance or a wake that is being produced when the speed of an object, i.e., any aerospace vehicle that is flying at a speed that is greater than the local speed in that medium or in that region, and that is been defined as the ratio of the speed of an object over the speed of the sound. It is equals to Mach number, and the Mach number is a dimensionless quantity, and that quantity will normally generalize the shock waves, and which will show us if the shock waves is it at the flow of the fluid that is passing over a slender body. So generally shock waves is being starts from transonic onwards, then from transonic to supersonic to hypersonic. Generally hypersonic can be as ignored because this is only goes for the aerospace vehicles that is flying above the ozone layer, that is for instance rockets that is floating that is entering into the space from the earth. So for now we can, for general purpose we use transonic and supersonic. If you have flight from one destination to another, then you must have went through transonic, because transonic are the flows that passes over a slender body of an aircraft that is passing through a Mach number closer to 1. A general example is given here, and this is an airfoil. A brief statement to airfoil can be noted as a thin or infinitesimally thin section that is cutted from the wing and that shown in the xy coordinate, and any airstream that is passing over this airfoil will have a fluid flow properties variation. So that is the variation will only be absorbed for a cambered airfoil, which is this. This is a non-cambered, that is a symmetric, and this is non-symmetric, that is cambered. Right. So this is a transonic. How? Because the first point at a big picture, the Mach number is less than 1 but the greater than 0.8, meaning that the aircraft is assumed to have a turbojet engine, because any aircraft that is moving with a Mach number less than 0.3 will be noted as glider aircraft, or having a propeller flight, which is produces thrust from propeller blades rather than having a turbojet engine. So this is a general civil aircraft or any military aircraft that has a turbojet engine, and so having a Mach number less than 1 but greater than 0.8 at the far stream. But when the consideration takes place at over this slender body of this thin airfoil, why should I say thin airfoil? Because the region, the thickness is very small compared to a thick airfoil, and this is can be proven as by the shape of this airfoil. So the thickness reduces a lot at the rearward of the airfoil compared to the forward of the airfoil. That is this trailing edge, the leading edge. So at the leading edge, the stagnation pressure is 0, and the pressure gets reduced on the leading edge of the airfoil compared to the trailing edge. Here the pressure is high, but the here pressure is low, and the velocity is also reduces. So, and the Mach number here is greater than 1, but here it gets reduced less than 1. At this region is greater than 1. So what we can conclude is that this dotted line signifies the shock waves, which are, so as I mentioned above before, shock waves can be only applicable for Mach number that is greater than 1, and this is a transonic flow, that is a mixture of subsonic and supersonic. This is a supersonic region, this is a subsonic region. This is supersonic and this is subsonic, and here the Mach number again reduces to 0.8, between 0.8 and 1 from the greater than 1. And so what we conclude that any aircraft that's moving in a transonic speed or supersonic speed or hypersonic speed, that it will have a fluid properties change. Number one, that the velocity, Mach number, and total stagnation pressure, which is this, will reduce as the shock waves will improve, and the temperature, entropy, pressure, density gets increased when the shock waves being improved or being generated. It's never been such like that a velocity increases when the shock waves occurs or Mach number increases when a shock waves occurs. That is completely a vague, which is a nonsensical term, nonsensical for aerospace applications. It is not always, and it's not always that the Mach number should be greater than 1. It will reduces, it can have a less than 1 as well in this region, because the slope here gets straightened or linear. Right, so these are the properties: pressure, temperature, entropy, pressure, density. These are increases as the shock waves occurs, and velocity, Mach number start. Total stagnation pressure decreases. So this was a brief introduction to shock waves.